All right, guys, welcome back. Today we're going to talk more about, I guess just a little bit of reviewing about the scientific method, but what we're going to focus on today is how we can find the parts of an experiment out of a description, or how we can take a question and make our own experiment. Because coming up, starting tomorrow, you are going to begin creating your own experiments. So today we're going to look at how we do that and a little bit more about the scientific method, because I'm sure looking at this assignment, there's only like two main questions on this page, like two problems, but we probably struggled just looking at it. So let's get into this. And first we're going to go over this, and then we will work with some other assignments. So let's open this with Cami so we can look at it. So when we are trying to find the parts of an experiment, remember we got to ask ourselves these good questions. What were they trying to figure out? What were they testing? Those are the main things we're looking for. So we're going to get someone else's work and we're going to try to find the parts in this assignment. So in 1887, a strange nerve disease attacked people in the Dutch East Indies. The disease was beriberi. Symptoms of the disease include weakness and loss of appetite. Victims often died of heart failure. Scientists thought the disease might be caused by bacteria. So that sounds like they've got a scientific question. So let's highlight that. So scientists thought the disease might be caused by bacteria. They injected chickens with bacteria from the blood of the patients with beriberi. The injected chickens became sick. However, so did a group of chickens that were not injected with bacteria. One of the scientists, Dr. Eichmann, designed a new experiment based on his own observations. Before the experiment, all the chickens had eaten whole grain rice, but during the experiments, the chickens were fed polished rice. Dr. Eichmann researched this interesting case and found that polished rice lacks thiamine, a vitamin necessary for good health. Just a side note, thiamine is one of the B vitamins, so beriberi is actually a B vitamin deficiency. All right, so it says state the question or problem that Dr. Eichmann investigated. So let's highlight that. So a strange nerve disease attacked the people. The disease was beriberi. So that's his problem, is beriberi. So we can write that. He was studying the disease beriberi. He didn't know what caused it. So the original hypothesis, scientists thought the disease might be caused by bacteria. I already highlighted it. So that's what they thought. That's their hypothesis. That was their first guess. So we're going to put that for number 2. It's caused by bacteria. So what was the independent and the dependent variable? So, we're going to assume that they're talking about the first experiment here. I know that's a little bit confusing, so we're going to assume that. So in the first experiment, what they wanted to know the effect of the bacteria, so that was independent. All right, so what did they measure? What were they looking for? They injected the chickens and seeing if they became sick. So dependent is whether or not the chickens got sick. So this is interesting for us to look at right here, is sometimes in science, our dependent variable isn't going to have a bunch of numbers by it. What we're measuring or looking for, the thing that happens when we do a test, isn't always, the word is quantifiable. You can't put a number to it. But we can look and see whether or not the chicken got sick. It's not like we're looking for he got more sick than the others. Did he get sick? Did he not get sick? So that's dependent. So a statement that summarizes the results. So we have to look at what happened. So the injected, the test group and the control both got sick. Did you notice that? They injected chickens with bacteria from the blood of patients with beriberi. The injected chickens became sick, but then the control group, so both the chickens with the blood injected and the control group got sick. So how should he test his new hypothesis here? So Dr. Eichmann thinks that there's something to do with the rice. So his new hypothesis is that thiamine, right? So he researched an interesting case and found that thiamine was what it was. So let's highlight that. Is that not doing it? Oh, okay. Sorry, guys. Okay, so how should he test this new hypothesis? First, we got to figure out what the new hypothesis is, right? Oh my gosh. So he researched what happened with the rice the chickens were eating, and he found that polished rice lacked thiamine. So his new hypothesis then, let's make a text box. Sorry, I did it wrong. So sorry. The new hypothesis we have is that thiamine causes beriberi. So we could write that as an if-then if we wanted to. So this is the new thing he thinks is going to happen. So if we wanted to do if-then, we said if a person or person lacks thiamine in their diet, then they will get sick or develop beriberi. So then how he could test this? He could test this, so we know that he wants to test the effect of thiamine. So if that's the thing I want to know the effect of, that makes it independent. By giving one group of chickens at enough or adequate thiamine and feed the others a diet low in thiamine. So how we took that hypothesis and we figured out how we wanted to test it, that is an important thing you're going to have to do starting tomorrow. Okay, so I'm going to give you a second, take a deep breath, absorb that information. I know that was a wild ride. Okay, let's look at the second one. So how penicillin was discovered. In 1928, Sir Alexander Fleming was studying Staphylococcus bacteria growing in culture dishes. By the way, this is a true story. He noticed that a mold called Penicillium had grown in some of the dishes. A clear area existed around the mold because all the bacteria that had grown in this area had died. And the culture dishes without the mold, no clear areas was present. So guys, there's a story, I'm not sure how true the story is, but legend has it that the reason mold was growing on his petri dishes was because someone was really not doing their technique correctly, and they were eating their lunch with the open petri dishes, and little crumbs from the bread had fallen in and they'd molded, and they accidentally discovered penicillin because of that. It's true that it was the mold that did it. I don't know if it's true about the sandwich, but it's a great story. Anyway, that was an aside. So Fleming hypothesized that the mold must be producing a chemical that killed the bacteria. He decided to isolate the substance and see if it could kill the bacteria. Fleming transferred the mold to a nutrient broth solution. This solution contained all the materials the mold would need to grow. After the mold grew, he removed it from the nutrient broth and then added the broth to a culture of bacteria. He observed that the bacteria in the culture died. His experiments were later used to develop antibiotics. Okay, so a question. So we have to look at what happened. So he observed, because remember we start with this with an observation a lot, he observed that where the mold grew, there was not, bacteria didn't grow. So question or problem. So his question was, what made bacteria die around the mold? So that was his question. So he made a hypothesis to answer that question. So he hypothesized it was a chemical from the mold that killed the bacteria. So it even tells you he hypothesized. So they gave that to you. So let's highlight that. Fleming hypothesized that the mold must be producing a chemical that killed the bacteria. So we're going to put a text box. You could even do that word for word off of there. Or you could say his hypothesis was if there is a chemical produced by the mold that kills bacteria, then let's see what he did. Then broth with mold growing in it will kill the bacteria. All right, that's a little bit hairy, and we had to do a little bit, we had to read this and do our best with it. So that's what he thought would happen. So we could even just use this because in science, they don't always use if then. I want you guys to use if then. But if you just wrote that he hypothesized the mold must have a chemical that killed the bacteria, I wouldn't count it wrong on this assignment. I'm going to be real. So how was the hypothesis tested? So it says right here, he transferred mold to a nutrient broth. This solution contained all the materials the mold needed to grow. After the mold grew, he removed it from the broth and then added the broth to a culture of bacteria. So how was the hypothesis tested? They're asking you for like the procedures that he followed. So let's put that in here. Okay, so let's try to make it short. He grew mold in broth, moved the mold, then put the broth onto plates with bacteria. Okay, so result. What happened next? So he observed that the bacteria in the culture died. Easy. Observed that the bacteria in the culture died. So you know what I can go back and do for you guys? I can highlight where I got this information from, if that will make it easier. There we go. Okay, the bacteria, the plates, so we'll use in the culture. That's what they said. We'll say in the culture. And the culture died, period. Okay, this experiment led to the development of what? That's word for word out of here. Fleming's experiments were later used to develop antibiotics. I don't know if you guys understand quite how important this is. We will talk about this in Unit 1 when we get there. But before antibiotics, people just died. In World War I, a lot of people just got sick and died. World War II, they had antibiotics, and it was totally different. In the Civil War, more people died from illnesses than did from fighting. Fun fact. Anyway, so let's put this on here real quick. Okay, antibiotics. Okay, so this is what we have to do. I'm going to open up the assignment and show you the one that I'm going to expect for today. It's basically the same thing. I think it's a little bit simpler than this, but there are more questions to answer. So let's look at this with Cami real quick. I'm not going to do all of them. I just want to make sure y'all know what it looks like because I know this video is already dragging on long enough and I don't want to take your whole day. Okay. So we got about 4 of them that you're going to do today. It's not quite as complicated. A lot of this is going to be word for word out of here. Okay, so Smithers thinks that a special juice will increase the productivity of workers. He creates 2 groups of 50 workers each and assigns each group the same task. In this case, they're supposed to staple a set of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of papers each group has made. So a control group. Remember, a control is something that doesn't have what's being tested. So take our text box, left click. So what are they testing? I guess we could skip down and do that. That's probably easier. So what are they testing? They want to know the effect of the special juice. So who isn't getting special juice then? Who's the control? So it says group B is not given special juice. So group B without the special juice. Okay, dependent. What am I measuring? So they measure, it says they're counting how many stacks of papers each group has made. So that's what they're measuring. Of papers each group makes. So hypothesis, what does Smithers think will happen? It even tells us that Smithers thinks that the special juice will increase the productivity of workers. So I need to phrase that in if-then format. So if a worker drinks the special juice, then our dependent variable is the stacks of papers. We think that we'll staple more papers. All right, his conclusion. So it says group A with the juice made 1,587 and group B made 2,113. So his conclusion is obviously that the special juice does not help workers staple more papers. And how could it be improved? Is there a problem with what he did? Okay, how does he know it was the special juice that had an effect? What if the workers ate something weird in the break room? So he needs to, let's see if I can move this box. He needs to check his constants So that would be, is everything they ate the same? Were people sick before they came to work? He also might repeat his experiment to get better, or to make sure his results are valid. Okay, so that is what I expect from you today. Like I said, be on the lookout tomorrow for another video about what we're going to do with our Design Your Own Experiment project. Good luck, and I'll see you guys in the next video. Take care.